This tan delta is also known as loss tangent or dissipation factor. So we'll discuss how this E prime and then E double prime is measured. Let's say in a simple terms, if you have a ball, a viscoelastic polymer ball, which is strike against a elastic surface in this direction, then it will bounce back. And now, for example, if it has bounced up to this side, here initially it was up to this side, and then this side we call it storage modulus, the amount of energy which is stored in the material. And now it has bounced to this once you strike to the surface, elastic surface. Now the difference between these two, we call it E double prime. So this is a loss modulus and this is elastic storage modulus. Okay, so this is storage modulus, this is loss modulus. This is in simple terms. Okay, coming back to glass transition temperature. Now glass transition temperature is a second order thermodynamic transition. Tg is a second order thermodynamic transition. Sometimes it is also referred as a pseudo second order thermodynamic transition, but mostly it's a second order thermodynamic transition. And whereas Tm, melting temperature, and boiling point, or that is also known as evaporation, right? The temperature at which the material evaporates or boils. This is okay, it really doesn't matter which symbol it is, but the boiling transition. So these are first order transition, first order thermodynamic transition. So why this is so? Tg is second order thermodynamic transition, because as we saw in the previous case, that when you plot the volume as well as the enthalpy, both show only a change in slope, whereas in case of melting temperature or the boiling temperature, with respect to time, with respect to temperature, there will be a discrete change. There will be a discrete change in the volume. Let's say this is a volume. So when you plot volume versus temperature, let me plot it in a better volume versus temperature. In a amorphous material, you will have a change in the slope. Only there is a change in the slope. this is Tg. Now if you take a semi-crystalline material as like a polymer which is both amorphous, this is amorphous, this is semi-crystalline. So what will happen at melting temperature, you will have a discrete, a jump in the volume, is a significant volume change with respect to the temperature. So wherever this kind of behavior, this discrete change is known as first order transition. This is a first order transition, and this is a second order transition. And when you have a crystalline material which doesn't exhibit a Tg, so that will look like this. Okay, so there will be a volume change. This is a crystalline material which only exhibit glass transition, melting temperature. And this is also known as second order transition, mainly because the second derivative of Gibbs free energy with respect to temperature is a discrete. Okay, so this is a first order derivative of the Gibbs free energy with respect to temperature will show a discrete behavior in the first order transition. The second order transition, the second derivative of Gibbs free energy will show the change or the jump.